morning, ladies and gentlemen. Welcome to the technical session of Spatial Sciences of the Annual International Research Conference 2022, Faculty of Built Environment and Spatial Sciences of General Sir John Kotalawala Defence University. This session will be evaluated by Architect, Associate Professor, Dr. M.N.R. Wijetunga, Dr. Ravihansa Chandrathilaka, and Planner, Dr. Upuli Pereira. This technical session will be chaired by Dr. Wathsala Gunawardena, Senior Lecturer, Department of Town and Country Planning, University of Moratuwa. Now, I cordially invite the report of the session, Survey and Planner, C.P. Ranawaka, to introduce the session chair.
Good morning, everyone. It is a great pleasure and an honor to be introduced in the chair of the session. Dr. Wathsala Gunawardena is a senior lecturer at the Department of Town and Country Planning, Faculty of Architecture, University of Moratuwa, Sri Lanka. She obtained her bachelor's degree in field of agricultural engineering from the University of Peradeniya. She has obtained 2 master's degrees in the field of remote sensing and GIS from Andhra University, India, and from the University of Tokyo, Japan. She obtained her PhD in civil and environmental engineering from Saitama University of Japan. She has been attached to the Department of Town and Country Planning for more than 14 years and has shared her knowledge and experience with the undergraduate and postgraduate students in the department and several other universities of the country. She has carried out many inspiring research studies in the field of remote sensing and GIS while publishing them in reputed journals and conferences. Dear Madam, I cordially invite you to chair the session.
Very good morning to all of you. Thank you very much, Mr. Ranawaka, for the kind words introducing me. Okay, now we are going to start the first session of the day. So first, let me call all the presenters to the head table. This is a great opportunity for me as well to share the knowledge and also to getting meeting each other. So now let's start with the first presentation. The title of the presentation is Review on the Height, Datum, Unification in Sri Lanka. There are 3 authors. Mr. K.P. Manuranga will do the presentation. Mr. K.P. Manuranga have completed his basic degree in BSc in Surveying Sciences and currently reading MPhil at Faculty of Graduate Studies, Sabaragamuwa University of Sri Lanka. He is currently working as a lecturer at the Department of Spatial Sciences of the General Sir John Kothawala Defence University. Mr. Manuranga, now over to you.
Good morning all. I'm KP Manuranga from the Department of Spatial Sciences, here to present our research work under the title of Review on Height Datum Unification in Sri Lanka. The study was co-authored by myself, Dr. H.M.I. Prasanna and Dr. H. Lakmal. Accordingly, we'll move to the content of this presentation. Here's the content. In any country, the National Geodetic Control Network is considered as most significant part of surveying and mapping. It should be the framework for any surveying like geodetic construction, engineering, mapping or hydrographic. The network should be consistent with horizontal, vertical coordinates with higher order accuracy to fulfill the requirements of the survey needs within the country. In the concept of the positioning, the height of a point with a reference to a vertical datum is an important aspect. Generally, to determine the height component, spirit leveling is adopted with reference to an equipotential surface. An equipotential surface is defined as an infinite number of points where the potential of gravity is always the same. For that, geoid is considered as an equipotential surface, which is commonly used as the mean sea level in vertical referencing. The concept of the unification of height datum becomes increasingly interesting nowadays, which makes the comparison of various datums in different regions possible. In this research work, the research question addresses the height datum unification method, which are associated with the unified vertical concept in surveying. Subsequently, in order to reach the above-mentioned research question, the main objective of this study was to identify a suitable vertical datum unification method that can be applied as vertical datum in Sri Lanka. This research work is mainly based on reviewing research papers, research articles that were composed of the geoid itself as a vertical datum, mean sea level itself as a vertical datum, unification strategies in a vertical datum determination. When it comes to the selection of geoid as a vertical datum, the geoid is defined as the potential of particular surface of the Earth's gravity field according to the Soderberg 2013. The best idea regarding the geoid was given by Amin and others in 2019. They defined the geoid as equipotential surface of the Earth's gravity field that gives the best model for the undisturbed mean sea level with the sense of least square. When it comes to the mean sea level itself as a vertical datum, there are more than 100 local vertical datums exist, and most of them are based on the average in sea level observation of a single or multiple primary tide gauges, assuming that these tide gauges coincide with the geoid according to the Balasubramanian 1994 and Datum and others in 2011. Balasubramanian 1994 further mentioned that those datums adopted average mean sea level observation over 19 years of tidal observations. Within the geoid literature, it can be identified different strategies and approaches are used to define the unified vertical datums around the world, and it is one of the most significant tasks of the International Association of Geodesy. Within the unification strategies, different strategies can be identified for the unification of vertical datums. Those are spirit leveling with the combination of gravimetric observations, oceanographic approach, and lastly, geodetic boundary value problem approach. Spirit leveling with the combination of gravimetric observation was used to connect two or more local vertical datums in some countries. As example, United European Leveling Network 1995-1998 was upgraded by using this method and formed European Vertical Reference Network by having centimeter level accuracy. Another typical example is vertical datum adjustment of the North American Vertical Datum 1988. When it comes to the second one, as for the second strategy, oceans are the fundamental obstacles to the height datum unification, since it is not possible to conduct direct geodetic leveling on the surface of the ocean. To overcome this problem, potential differences were derived from ocean leveling using geostrophic and hysteric leveling method with the help of mean dynamic topography. Mean dynamic topography is the average topography of the ocean relative to the geoid caused by dynamic process such as oceans, ocean tides, currents, etc. When it comes to the third strategy, the geodetic boundary value problem is commonly used in nowadays to determine the unified vertical datum over the countries or continental wide. According to Sanso 1981, if considered in the shape of the boundary and the value of the potential, it gives the Dirichlet problem. And if considered in the value of the potential as well as the gravity vector all over the boundary, it gives the Molo density problem. Amos and Featherstone, 2009, used an iterative process in GBVP approach to form a unified vertical datum for New Zealand, combining 13 vertical datums. The research done by Shang and others in 2020 used GBVP approach-based remove compute restore method to define a vertical datum offset between local and global vertical datum in Australia, the USA, and Hong Kong. For this approach, it can be used terrestrial gravity data, satellite gravity data, Earth gravity models, leveling data, and global navigation satellite system data for the unification process, and it gives the millimeter level accuracy rather than above mentioned two methods. When it comes to the Sri Lankan vertical datum, it was originally named as Ceylon Level Net, and it was started in 1926 and completed in 1930. This network consists with 27 two-way level lines and 59 fundamental benchmarks. The zero MSL was observed using 3 different discrete located self-recording tide gauges at Colombo and Trincomalee between 1923 and 1933. These observations were used to define the origin point of the Ceylon level net according to Jackson 1936. But before that, they decided to use tidal observations done in Trincomalee, Colombo, and Galle because these 3 locations gives the daily prediction of the tidal data of the Indian Ocean. It was initially decided to use Colombo and Trincomalee as the zero height location for the precise leveling, but the Ceylon level net was adjusted using only Colombo tidal observation observed by the Great Trigonometric Survey of India during the time period of 1884 to 1889 according to the price 2013. When considering the cluster changes and other geophysical changes, the mean sea level observation done in 1884 to 1889 period are not sufficient for the present day surveying work, and MSL observations done in 130 years ago are not sufficient for the fixing the vertical datum in Sri Lanka. And also, this was pointed out by Abhiratna and others in 2009, and they further mentioned that the possibility of having ellipsoidal height biases in Sri Lankan GPS datum. The recent research done by Prasanna and others in 2021, they were developed new model to determine the relationship between local vertical datum and lowest astronomical tide. Also, further, they mentioned that the absence of gravity data over Sri Lanka was a major concern for this kind of survey or study, and global-based local geoid was suggested as a result. When it comes to the discussion, still Sri Lankan surveyors use the level network data observed in the 1884 to 1889 period for any type of survey work. According to the Intergovernmental Panel on Climate Changes 2014, they have clearly mentioned the rise of sea level change by approximately 3.2 millimeters per year and Sri Lanka faced a huge tsunami effect in 2004 due to the plate tectonic movements that happened on the Burma and Indian plate. There is no such evidence of the upgrade or changes in the zero height origin and also the fundamental benchmarks of the vertical datum of Sri Lanka after this incident. Therefore, when considering the above-mentioned factors and other global geophysical changes, the mean sea level observation done in the time period 1884 to 1889 were not sufficient for the present-day survey work. Therefore, as for the conclusion of this study, with the help of the geodetic literature and the history of the Ceylon level net, it can be stated that the unification of the local vertical datum is an important work for the present-day surveying and mapping work. Therefore, the remedy for this is to incorporate equipotential surface like geoid as the vertical datum. It is possible to say, as for Sri Lanka, it is better to use the GBVP approach method to find the vertical datum offset between local vertical datum and the global geopotential model like geoid. The further direction of this study is to apply the GBVP approach to the vertical datum unification of Sri Lanka and form a unified vertical datum for Sri Lanka that can be used for any kind of survey activity within the country. These are the references that use for my this presentation, and thank you.
Thank you very much, Mr. Manuranga, for finishing your presentation on time. I am certain you have some questions to ask from Mr. Manuranga, but let's have our question and answering session at the end of all presentations. So I think your presentation is very clear and interesting. Thank you. So now let's have the second presentation. The title of the presentation is Analyzing the Effects of Land Use and Land Cover Changes on Paddy Cultivation Using Remote Sensing, a case study of Sooriyawewa, Sri Lanka. There are three authors. Ms. C.G. Malavipathirana will do the presentation. Ms. Malavipathirana, over to you.
Good morning, everyone. I am going to present my research topic. In here, you can see the topic, analyzing the effects of land use and land cover changes on paddy cultivation using remote sensing, a case study of Sooriyawewa, Sri Lanka. Now you can see the content of the presentation. First one is introduction. In here, I explain the background of my study. As you know, land is a limited resource. In present, land use, land cover changes are mainly occurred due to the physical developments and the agricultural purposes. Analyzing of these land use, land cover changes are very important for the land surveyors and the spatial planners because for the spatial planners, because land cover maps provide the details to realize the landscape properly. To examine the past changes, we need different years of land cover maps, and this information useful for the authorities to evaluate the past management decisions as well as the possible effects of their current decisions before they are proceed. In the past, Sri Lanka is one of the prominent countries for the rice production in the world, and paddy is the major crop and mostly grown in Sri Lanka. However, the whole area allocated for paddy cultivation is not being cultivated due to various reasons, such as water shortages prevailing in unsettled conditions. Due to the COVID-19 pandemic period, we'll discuss the importance of fresh and nutrition foods from small-scale rural producers. Also, Sri Lanka had to face some issues on food security, so crop monitoring is very important. Crop production acts a huge role in food security and economic development of a country. I identify research questions from my problem, then I develop general objectives from the research questions. Specific objectives are used to fulfill my general objective. My objective was to identify the land use land cover changes on paddy cultivation. So I examined what are the existing monitoring systems, paddy monitoring systems. For this part, I studied past research papers and interviews and discussed with farmers and experts in paddy cultivation. Crop monitoring in many countries relies on traditional data gathering such as field reports, field receipts, but these are frequently subjective, expensive and time consuming. Until now, Sri Lanka only used traditional data collection methods for paddy monitoring. Then I want to identify what are the applicable technologies for monitoring paddy cultivation. This project is a case study in Sooriyawewa Divisional Secretariat Division, Hambantota District, Sri Lanka. Out of the 12 divisional secretariat divisions in Hambantota District, Sooriyawewa is the driest. Hambantota District ranked as the 5th place in rice production in Sri Lanka. The main occupation of the people living in this area is paddy cultivation. Today, paddy and other field crops such as banana, pomegranate are the most cultivated crops in Sooriyawewa. This research conducted with secondary data. I use Landsat satellite images, paddy cultivation data, and population data. I use ArcMap software and Google Earth software. In this section, I explain how I conducted my research. Firstly, I downloaded Landsat satellite images from Earth Explorer. Yala and Maha is the main paddy cultivation seasons in this area, and Maha is the most paddy cultivation season in Sooriyawewa. Maha season is during period from September to March in the following year. So I downloaded satellite images between January-February period, and also I maintained 5 years of gap in the map series, and I did the analysis part using ArcMap license software. First I applied radiometric correction for each image, and after I did the supervised classification and did the accuracy assessment part. Then quantified the land use land cover changes for each image. Basically divided land use land cover changes into 6 parts: paddy, water bodies, other crops, bare lands, forest and build-up areas. Next I compared my outputs with the paddy cultivation data which issued from the Agrarian Office, Meethajadura, population data and climatic factors. Then I analyzed the underlying causes for the land use land cover changes, and in here I contacted farmers, agrarian officers to take that general idea about that. Results and discussion. So I created 9 classification maps for 6 land use land cover categories using supervised classification: 1980, 1988, 1992, 1997, 2000, 2005, 2010, 2014, and last one is 2019. I made the line chart and you can get a clear idea about the land use land cover changes easily. In here, this chart shows the rise and declines of each land use land covers from 1980 to 2019. You can see the paddy areas are declination. Change detection is a technique for determining how much a region has changed over time. Using the post-processing approach of the study, the change in coverage, annual change rate, and the percentage of annual change rate between images were determined. Here I show you land use land cover changes between 1980 and 2019. In order to conduct an appropriate study of land use land cover variation, it is necessary to establish clear differences between 2 categories: the source and underlying causes for this process, and the direct and indirect elements. Construction activities, deforestation, and other crop production have reduced the area under paddy. As a result, there is an indirect increase in temperature, decrease in rainfall, increase in air pollution, natural waterlogging, and drought. The findings were compared with the statistical data in this section. So I compared paddy statistical and population data. Population is a major social component. According to the population data in Sooriyawewa Divisional Secretariat Division, it has expanded greatly since 1981. Identified underlying causes for land use land cover changes. I identified 4 causes. First one is water shortages. Due to the geographically and seasonal unequal distribution of water, the drier areas of Sri Lanka are occasionally vulnerable to water shortages. June, July and August are the most problematic months in dry zone. As a result, climate change, weather patterns have changed and forecasted rainfall has not come as predicted. Second one is alternative crop cultivations. Banana, watermelon, pepper, pomegranate and passion fruit are the most prevalent alternative crops in this area. And the study conducted in Hambantota in 2015-2016, they found that farmers choose to produce banana in paddy areas for economic gain. During the period 2005 and 2015, one of the government of Sri Lanka top goals was to upgrade the infrastructure and start numerous new projects in this area. Mahinda Rajapaksa International Cricket Stadium, the Southern Expressway were the major projects were began in this area. These construction activities mainly caused for the land use land cover changes in Sooriyawewa Divisional Secretariat Division. And last one is pest and diseases, fertilizer problems. It is critical to reduce and avoid natural dangers such as pests and illness of paddy production. Currently, the government is taking steps to encourage the production and usage of organic fertilizer in agriculture, and they expect to boost crop yield, improve soil fertility, and cut chemical fertilizer imports. However, due to the lack of chemical fertilizers, farmers are having a difficult time cultivating. In previous section, I told you rapid development activities in Sooriyawewa is one of the underlying cause. You can see easily the variation in here. 2016 image, large paddy areas can be seen, but in 2019 image has limited to paddy cultivation areas. This study identify what are the reviewed system for monitoring the land use land cover changes and applicable remote sensing technologies, then quantify the land use land cover changes over paddy cultivation during the past 4 decades, and finally examine the underlying causes for the land use land cover changes. Traditional methods of crop monitoring have associated issues, and remote sensing technologies beneficial for evaluating natural resources and management. According to the analysis, there are also decreasing paddy areas, but build-up areas and other crops are significantly increased. Given that scenario will continue in the future, Sri Lanka may confront issues pertaining food security, being unable to supply for the demand. If the government pays attention to this and takes necessary action, this crisis can be mitigated. The situation can be minimized by providing necessary facilities to the farmers for cultivation, improving their living conditions and educating them about paddy cultivation and preparing them for extreme weather conditions such as droughts. This is a temporal problem in this area, so this project is essential for the relevant authorities for decision making. These are some references which I used for my study. I would like to express thanks for all the people who gave me help us in many ways. Thank you all of you.
Thank you very much, Ms. Malavipathirana, for your interesting and simple presentation. Now, for this presentation also, let's have the questions and answering at the end. Now, let me introduce the third presenter. She is KGES Dias. Ms. KGES Dias is an undergraduate student at the Department of Spatial Sciences at the Faculty of Built Environment and Spatial Sciences of General Sir John Kothalaula Defence University. She is going to talk about impact of flood on the built-up environment, a case study of Baddegama DS Division. Ms. Dias, over to you.
Good morning to all of you. I am Erandi Dias from the Department of Spatial Sciences and here to present our research findings under the title of Impact of Flood on the Built-Up Environment, a case study of Baddegama TS Division. This is the content and I'll hope to discuss each and every topic during this presentation. So let's move to the introduction part. In here, I would like to give a brief introduction about my research. Actually, Sri Lanka is suffering from various natural disasters. Among those natural disasters, flooding is the greatest threat to people who are living in the lowland plains. Not only for Sri Lanka, but also floods are one of the world's most pervasive, devastating, common natural disasters. According to the disaster risk reduction in Sri Lanka, they were mentioned that the year between 1990 to 2018, the most devastating natural disaster was a flood. As a percentage, it was a 58%. In other hand, flooding is the natural calamity that may cause damage to the properties, built-up environment, infrastructures, vegetations, even living beings. So in my case, I had decided to find in the impact of a flood on a built-up environment. When we come to the research problem and objective, always research problem like these will lead to give answers in a spatial way. As shown in this figure, according to the International Organization of Mitigations, they were mentioned that there were more than 500 partially damaged houses and more than 100 fully damaged houses were reported in a severe flood on 2017 from the Baddegama area. These kind of things are happen due to lack of the pre-identified system. So my research problem is to Baddegama area has been hit by floods almost every year up to now, but so far there is no system to identify the vulnerability of the built-up area. The ultimate goal of this research is to identify the risk of the built-up area that we vulnerable in a flood. Now we come to the methodology part. In here, I would like to talk about the methodology that I applied in this research. For the easiness of the understanding, I divided it into 3 subtopics as study area, data used, and research methodology. As the study area, I selected the Baddegama DS division, which is situated in the southern province of Galle district. Actually, Baddegama DS division is subjected to being flooding each and every year. Because the main contributing factor, otherwise the Gin River is flows across the Baddegama DS division. These are the another examples for why I am selecting Baddegama area as my case study. The first figure shows that the number of rainfall days per month in a year. Actually, you can see that there are more than 14 days are subjected to being rainy days per month. And second figure shows that the quantity of the precipitation, the highest precipitation was reported in the month May as the 302 millimeters. These are the factors that are affect for the flood in this area. When we come to the data that we used, types of soils, water features, slope data were derived from the digital elevation model, and land administrative boundaries were obtained from the Survey Department of Sri Lanka. And the land use land cover data were obtained with the help of Landsat 811 images from the USGS Earth Explore, and finally rainfall data obtained from the Meteorological Department of Sri Lanka. When we come to the research methodology, first of all, I have to download the Landsat 8 image. Then I did the pre-processing parts, then perform the normalized difference built-up index to prepare the NDBI map. After that, land use land cover map was prepared through a supervised classification. In other hand, rainfall data that we obtained from the Meteorological Department was subjected to spatial interpolation as Kringing, Spline, and IDW. After that, I did the accuracy assessment to select the best interpolation, and finally, using that method, map the rainfall data. Then with the help of land use land cover, slope, soil, water features, and rainfall data were used to perform the analytical hierarchy process and weighted overlay method to prepare a flood inundation map of this area. Then I overlaid the NDBI map and flood inundation map to finally identify the affected built-up area So when we come to the results and discussion, first of all, I have to prepare the layers that we want to this research. So first of all, I prepared the rainfall map of this area, but there was a question how to select a best suitable interpolation technique. So I did the surface interpolations using spline, kriging and inverse distance weighted method. And finally, I calculate the root mean square error for identify the best suitable one. So finally I realized that the IDW is the best suitable one because the RMSE value is minimum in the IDW. So using the IDW interpolation method, finally I prepared the rainfall map. Then after preparing the rainfall map, the another layer is land use land cover. So that, as I mentioned in earlier, used supervised classifications for that, and this is the accuracy assessment for these. In this area, I divided into 7 subclasses as water, paddy, forest, tea, rubber, coconut and built-up areas. And finally, I achieved the overall accuracy as 89%. And this is the finally land use land cover map of Baddegama DS division, including the above mentioned 7 classes. After completing the preparing land use land cover map and rainfall map, another task was to give the weights for the criteria, so that I used analytical hierarchy process for that. And also to obtain the data, I hold a questionnaire survey from Baddegama area to well knowledgeable persons and collect the data from them, and finally I obtain the weights for the criteria. The right hand table shows that the weights that I obtain. And then next step was to given the scales for the sub-criteria also using the questionnaire data, and finally I perform the weighted overlay analysis to prepare a flood inundation map of Baddegama DS division. This green color shows that the low risk areas, yellow color shows that the moderate risk areas, and red color shows the high risk areas. The last step was to prepare a built-up area map. So that also used the supervised classifications and area divided into non-built-up and built-up areas. So in here also overall accuracy is achieved as the 84%. And this is the built-up area map of Baddegama DS division. And the red color shows that the built-up area of this area. Then final step was to overlay the built-up area map and flood inundation map of this area. Then I can obtain the riskiness of the built-up in Baddegama DS division. These 3 colors shows that the riskiness of the flood inundation in Baddegama area. And this is the summary of the results that we obtain. Actually, there are 54% of built-up area in a moderate risk and 32% of built-up area in a low risk areas and 14% of built-up area in a high risk areas. This pie chart also shows the summary of the results. As a conclusion, I can say that normalized difference built-up index effective to extract built-up areas. In my case also, it is very useful for an time-saving method, and freely available satellite images, Landsat 8 images and ArcGIS platform were significant for studies like these. And root mean square RMSE 8 to find the best suitable interpolation technique. In my case, it is very useful for finding the map the rainfall data in Baddegama DS division. Finally, supervised classification is important to make a land use land cover map suitable for the respective years that we want. These are the references that I used for this research and this presentation. And my sincere gratitude forward to the lecturers in the Faculty of Built Environment and Spatial Sciences. And furthermore, I wish to sincerely thank to the Survey Department of Sri Lanka and the Meteorological Department of Sri Lanka for providing all the digital data layers. Finally, thank you.
Thank you very much, Ms. Dias, for your nice presentation. I'm happy everybody finished on time, before time. And I have few suggestions for you, Mr. S, so we can discuss them at the end. So now let me introduce the last presenter. He is JPC Singhawansa. He's an undergraduate officer cadet who is pursuing a Bachelor of Science in Surveying Sciences degree at the Department of Spatial Sciences, Faculty of Built Environment and Spatial Sciences. He is going to talk about the use of unmanned aerial vehicles for facade surveying applications in Sri Lanka. So now it's time for you.
Good morning, ladies and gentlemen, and let's see how the use of unmanned aerial vehicles for facade survey application in Sri Lanka. The slide slash on the screen shows the sequence of my presentation. First of all, introduction, problem statement, research question, research objectives, literature review, methodology, results and analysis, and finally the conclusion and the references. The recent past decade, the building information modeling became a value for many application scenarios, especially in simulation, visualization, and support for taking decisions with regarding the details of the buildings. Generally, BIM modeling consists the 3D models and it represents the physical and functional properties of the building properties. The use of building information modeling was originally taken by the engineers and architects in the early stages. So we need to think about that, how it can be used as a differentiator, especially in surveying field. For the in detail of the introduction, I will try to evaluate it by considering the background information, statement of the problem, research question, research objectives of this research study. And UAVs are simply known as drones, is an important tool which is used into construction field nowadays. And those aerial vehicles or the flying drones are useful for in number of engineering, architecture and construction applications. With the advanced technology of itself, these type of firms are taking the drones as their working process with increasing the frequency. UAVs are yet emerging in the construction field and the image-based 3D reconstruction and modeling techniques. And drones act as flying cameras, which may be useful to capture the digital data and the image from the different kind of aspects. And basically, in this case study, I flow through with the use of the drone technology and image-based modeling with regarding the building information modeling and the facade survey. Recent development of the automation technique in the construction. Continuously, the BIM methods take the advantage of the digitizing process of the construction or the building sites. And drones are take part in the crucial part of this revolution. According to my research study, I will try to ensure that to fulfill the gap in between post-construction survey and as-built survey with regarding the construction practical in terms of digital documentation, site surveying, inspection and the safety. The slide slash on the screen shows the generic research questions. First of all, I will try to define what is the BIM and the 3D facade of the building, and the other one is how to use the drone images and its point cloud data for as-built surveys and 3D BIM modeling. In my research study, I will try to achieve the general object as the unmanned aerial vehicle for the facade survey application in Sri Lanka and get an idea about BIM modeling and facade surveying of the building, and to use the drone images and its point cloud data for as-built surveys and evaluate building information modeling. And here you can see the basic research studies that I used to apply for my research works. In here, you can see the flow of the methodology in my research study. In relation to that, first of all, I must need to select a suitable site for practice the survey, then plan how to conduct itself. After that, the digital data acquisition. Next part is the image processing, which related to the preparation of the digital images. Analysis of the data is the next important step, and then finally the process is complete and have to achieve the objectives and give the recommendations according to my case study. The slide slash on the screen shows the data analysis of this study. Especially in here, I try to use two survey techniques, and the efficiency level will contribute by the as-built survey drawing of the particular construction. The captured digital data will process through the two separate softwares, Pix4D Mapper and the Global Mapper. And the conventional method as traversing will conduct by total station. And finally, all the data will analyze according to the as-built survey drawing to compare the efficiency and the accuracy of this case study. Literally for this research, I had to use two stages of data collection. As per the first step, I had to conduct a total station traverse through the established control point, then need to assign the height details for the relevant control points, and therefore need to conduct a level line throughout these points. After the first stage of the data collection, as per the next step, the UAV training session was done by using DJI Phantom drone and capture the images in the whole building by piloting the drone. In here, simply you can identify the height details and the coordinate details of each control point. And basically in here, I try to check those coordinates by using the Body software to ensure the coordinates are correct. And this slide slash on the screen shows the orthomosaic images of front facade and the AutoCAD three-dimensional drawing of the bachelor accommodation building. And basically, orthomosaic details are dependent upon the captured UAV images processed through the Pix4D and the Global Mapper software. In here, you can see the as-built details of architectural drawing and the total station observations and the orthomosaic details in front door. In here, the present architectural and the topographic and orthomosaic details of front facade of the bachelor accommodation building. Those are the details trio of the window measurements of the bachelor accommodation building. When we come to the analyzing part, these are the measurement details of the front facade. In first table gives the differentiation in between architectural drawing and the total station observation. In here, some sort of differences are captured in total station observation. In the next stage, we can see the measurement details of the orthomosaic details and the total station observation. And in here, the maximum difference was captured by the orthomosaic and the topographic details was 5 millimeters. And considering wall details, it's 1 millimeter difference. For the door details and frame details are taken just 2 millimeters. Actually, when considering such kind of building, it is already gathered the total station details as much as possible level in the orthomosaic detail. And these two tables shows the captured detail of the windows and its facade detail. And actually, as per the front facade, both orthomosaic and total observations are nearly overlapped by each detail, and whole variations are in 2 millimeter level, and considering the actual details of the windows, the gathered results are almost in beta level. Here the conclusion of my research study. And literally, completing such research study, it can be argued that no new technology should be used in survey tasks without first evaluating its accuracy. For the experimental analysis, the data was taken by the Sokia Total Station and conduct a topographic survey to refurbish the bachelor accommodation. In the same manner, need to acquire the digital data by using the UAV images. And considerably, both of these processed data are in similar manner with regarding the as-built details and the captured images which are processed. Actually, piloting a drone is not simply an easy task. In here, we need to consider the conditions of the environment and the weather. And this digital data collection was basically dependent upon the high-resolution camera. Literally, in this research study, I have used Pix4D, AutoCAD, Global Mapper, Sokia Link software for experimentation, the acquired data. The image processing is basically dependent upon the Pix4D and the Global Mapper tools when it creating. In here, roll, yaw and pitch of the UAV was not considered as much as possibility of capturing the images and also the weather condition and the environmental background of this build-up area. This article established a link between two modern scanning technologies, the total station and the process orthomosaic image. Since the interoperability potential is extensive, it can be claimed that a connection established are just one small step based on the experiment gain. In today's world, countries try to reach the high-rise infrastructures when availability of the reconstruction process or the as-built process will have to do with some sort of modern technology like using UAVs. Especially in this research study, give the efficiency and the effectiveness of using unmanned aerial vehicles for facade survey application and efficiency in time cost, safety and the accuracy. And those are the references that I used to create my research study. Thank you.
Thank you very much, Mr. Singhawansa, for your nice presentation. Now we have time for the questions and answering. So it's time for the audience to ask questions from each presentation. So let's first give the chance to the first presenter, Mr. Manuranga. So he has presented about the high datum unification in Sri Lanka. So I cordially invite you to ask the questions from Mr. Manuranga. Do you have any questions? The question is there. Okay, you can ask it.
So good morning, sir. I'm 6261 Secretary MD Silva. Sir, your presentation is nice. And my question is, because of the changes of the earth plates, the tsunami happened. So how can we get a confirmation the benchmarks were changed or not after the tsunami?
Sri Lanka normally it has normally we are using the mean sea level observations for the tide gauges. Therefore, we have to check again the observation. It means we have to observe the mean sea level tidal data. After that, normally for the when we are getting the mean sea level, 19 years of observations to be taken, the data to be observed and check again.
Thank you.
Did you get the answer?
Yes, sir. It's mean we have to wait for nearly 19 or
No,
20
normally
years for the check the changes of the tide.
normally if we are considering if we are getting the mean sea levels, it has to be taken the 19 years observations. But like that way, the changes to be checked.
Yes. Thank you, sir.
Okay, thank you very much. Any more questions?
Now regarding the unification, as you mentioned, do you have any other methods like satellite images based on the aerial methods for the gravity measurements? Have you looked at any literatures how you can get unification for preparation of the geoid model?
Yes, sir. It was mentioned normally not that by using the images, gravity satellite gravity data can be taken from the sites, And also that by using the Earth gravity models, we can check that one, sir.
Okay, thank you very much. We can have one or two more questions. Okay, since they are, yeah. Then let's move to the next presenter. Miss Malavipathirana, she talked about analyzing the effects of land use and land cover changes on paddy cultivation using remote sensing, a case study of Sooriyawewa, Sri Lanka. So please ask questions or clarifications.
So Ms. Malavipathirana, you did a supervised classification for selecting signatures. So can you please explain that how you select the signatures? Just only a visual observation, or did you make a ground verification, or what kind of reflectors that you have taken?
So I use Google Earth and take training samples, and I use for the satellite images for that.
So you got the training samples from Google Earth?
Yes, sir.
That means basically a visual observation.
Yes. Oh, yes. Okay, sir.
So why didn't you check it practically, in practical aspects? Did you make any kind of reflectance collection from the ground?
Sir, I did my analysis from 1980 to 2019. For the past years, I can't do the field verification, so I...
But anyway, for the paddy land, the spectral signatures won't be changed very much, no?
So I used Google Earth for training.
I would like to add something for that. It is better you give the accuracy report in your presentation or in your research report. I didn't see it, so it is better if you add the accuracy report. Then everybody understood.
Okay. Thank you.
Yeah, I have one question now. As you mentioned about this classification of land use classification using the Landsat images, have you find anything regarding the paddy, abandoned paddy? Because as you take into account for the different categories, because as you know, this area maybe some of these things going to be abandoned. Have you come across anything related to that paddy changes of paddy lands?
So I categorize into 6 classes: bare lands, paddy areas, water bodies, built-up areas, and other crops. I also categorize the bare lands.
It's all on that, the abandoned paddies are
Yes,
going
sir.
on to that one.
I selected as...
Yeah, and when you talk about this, the highway you have mentioned, you show the area of significance because of the highway. Do you think that Landsat images have made, because this resolution is 30-meter resolution?
Yes, sir.
Do you feel any difference, because as you shown the image of the Google Earth, but when you take the Landsat, I don't think you can see much significance on that one. Have you noticed while doing the classification? Have you notified anything?
Yes, sir. Actually, Sentinel images have high resolution, but I can't use that because my study starts with 1980 and Sentinel starts with 2014. So I choose Landsat because freely available, and Landsat images have 30-meter resolution. It is okay for my study.
Okay.
Any more questions?
I would like to make a small suggestion that what Mr. Sivanandaraja indicated, right? For a Landsat image, you cannot get any data beyond 30 meters, right? 30 meters is the resolution. So in such a case, why don't you, maybe for further development, why don't you make some sort of hybrid classification? That means you can get the whatever the vector data for the highways and so-called features, and you may overlay it, and you can get that amount outside, that features outside, then you can do the classification for the balance area, kind of a hybrid classification, vector plus raster. kind of thing, right? It may give a more good advantage to improve your result in future, right?
As well, she could do image fusion technique with panchromatic images, and also she could see the time series data, Google Earth, and compare the result.
Paddy, the final amount, because how much of paddy was there and with the, what is the census data agrarian, have you compared it or have you checked anything? How much the existing paddy area on this one with the statistical report?
Sir, they have limited data, only written data. They only show the production data.
No, because they have some extent also, they have counted some extent with the tabular information. Have you checked that one, the figures?
Yes, sir.
How much difference there is? Any big difference, so as it is?
No, small differences.
Okay, thank you very much. Then let's move on to the next presentation. Ms. Dias. She talked about impact of flood on the built-up environment, a case study of Baddegama DS division. It's time for you to ask questions.
Dias, thank you very much for your interesting and very informative presentation. So in your research, you have identified most of the built-up areas in Baddegama are under moderate flood risk, and but still 14% of built-up areas are at high risk. What kind of early warning mechanisms are available in this area, and what kind of disaster risk prevention or reduction methods are applied in this area?
Actually, madam, still now there are no risk reduction and early warning systems, but there are some evacuation centers that are defined from the disaster management center.
Early warning systems available from disaster management center?
No, madam, there are no any early warning systems.
Okay, thank you.
Yes, Ms. Dias, I have a suggestion for you. You used a somewhat different approach to demarcate the flood inundated area. So it is better if you use Sentinel-1 data, radar data. So they are freely available. You can easily demarcate the flood affected area if you obtain images during flood event. And also if you obtain before flood and after flood also. So you need 3 images, before, during and after. And you could easily demarcate the flood affected area. And also you could predict for the future. And then it will be more effective or more successful comparison. Then you could overlay the urban area or the land use over the flood affected area and determine the percentage under flood. So I suggest you to think about it.
Thank you, madam.
I would like to add something for the benefit of the researcher. There was a discussion went on about the disaster information or the risk information. There is a system covering the Baddegama area, Pittabhaddara and other adjoining areas. So under Disaster Management Center, there is a well organized system, and especially under Disaster Management Center, there is monitoring stations of water level of the river. So I think 4 monitoring stations are there. So that is hourly monitored by Disaster Management Center as well as the Sri Lanka Navy. So in Galle Navy camp and the naval headquarters is monitoring hourly about the water level of this river. Okay. Then the rapid teams are allocated, and even though there is no flooding risk, the teams are already allocated to the divisional secretariats for rapid actions. Okay.
Thank you very much. Make us aware about that.
Yeah, this is also regarding risk reduction. Any recommendations that you have that you can make for risk reduction in that area?
Actually, sir, drainage system is not much very convenient for the people in this area, and the built-up areas are some of the built-up areas in a risk, but some of the factors are affect for that also, because the non-authorized built-up areas are also here.
Yes, I would suggest that you do an advanced research, make some recommendations. This paper can be presented after that. Yeah, so do the research and see. That's a good research that we have done, very pertinent to that area.
Okay, thank you.
Yeah, just to add to that suggestion, I can also suggest this is a very good field study you have done, and in the Greater Colombo economic areas, Western Province, they have done in early 2000 high flood levels for next 50 years. So they have a big document. So when they build, especially the designs, the building, high-rise buildings and all, they take the high flood levels for next 50 years, and they take precautions not to get affected with floods there. So you can extend this and have a very helpful in future building for the area. Thank you.
Thank you for the questions and suggestions. Any more?
Good morning. 6479 Junior Secretary UMSDKB. My question is, what is the resolution of the Landsat images for that your research?
Thank you for question. Landsat images have 30 meter by 30 meter resolution.
Thank you.
Okay, thank you very much. Any more?
Yeah, that is a good exercise that you have mentioned. I think we have to look at, as mentioned about this 50-year flood period, it also to have some, to add something to this research, because you are based on the purely with the digital elevation model and some of the category with the slope. I think it is better to include the rainfall data with the stream network, because then only you can add much, because when the streams getting flooded, it automatically affects the areas. Therefore, you have to add something with the stream network, then you have to use with the grass, with the flood modeling, then it can be improved, because one of the requirement is we have to find out the risk areas, because your subject was purely based on the satellite data and the digital elevation model, but you are not touched on the other side, like how the streams are there and the flow of water, and because it might increase suddenly, because that is one of the areas I think the officer mentioned they are taking hourly information. If you can incorporate that also into the system, then automatically you can identify what are the high-risk areas, especially the built-up areas, how they can get precaution. So you have to think of, in order to incorporate that one, but I have seen most of the areas in the hilly areas is not affected, and the low-lying area affected because of the your elevation model. But if you include that stream network and other thing, and your research can be extended further.
Thank you, sir. Thank you very much. Any more questions? Okay, then let's move to the next presentation. Mr. Singhawansa talked about the use of unmanned aerial vehicles for facade surveying applications in Sri Lanka. Over to you to ask questions.
Good morning, sir. I'm Officer Cadet JKG Vijay Singha. Sir, your research study That was interesting one. So my question is, what kind of analysis you used for that case study, sir?
Yeah, actually, I am using a feasibility analysis for this research study, and I have to compare both the conventional method of total station and the orthomosaic images which are taken by the UAV drone images, and accuracy assessment also based on the architectural drawing and comparison in between these total station details and the UAV orthomosaic processed images.
Thank you, sir.
Yes, please. Please. Can, sir.
My question is, can we apply your method for the urban area facade studies? And what are the constraints and limitations for if we are conducting such kind of facade studies in urban areas?
Of course, madam. Especially I am trying to reach the post-construction details, taken the post-construction details of the building in high-rise, especially the high-rise buildings. Basically, we are using those days total station for taking those post-construction details. For that, I can ensure that using this technique to use the high-path structures to gain all the details in when comparison to the total station details.
Okay, you mean it is easier than as architects we are doing like manually we are doing the facade studies?
Yes,
you
madam.
We can apply your method for the facade studies?
Yes, madam. Because when we consider the total station, it of bit of time and cost-effective method. And when using these UAV drone images, we can capture and process all the details within 2 to 3 days for the high-rise buildings.
Okay, thank you.
Any more questions? Okay.
Yeah, I think I have a small question and a doubt also, because as you mentioned about this auto-rectify auto image, that from taking that one, whether we can extract the door frames and that you have mentioned in your slide. You can extract the doors and other thing, because can you do it with these UAV images?
Yes, sir. For my research study, I used this bachelor accommodation building. For the I try to gain the door details and the other details because of the taken the small portion of the buildings. Also can gain the relevant details, accuracy level as per the total station details.
Now that the one of the issues is like architectural design, you need all this information, no building. Whether will it be possible in the UAV images to get the doors and windows, door frame, whether will it be able to do it?
Yes, sir.
Stable, and the direction is vertical, no, with this covered. That's why.
It's by the taking the altitude of the drone image and capturing data, we can use this method.
Mm-hmm. Yeah. Now normally we can take the area where the top floor like that, but taking the door frames and the windows, it's better knowing that you have done it. It's good. We can improve it also, because it's only the isolated building, maybe you have a chance to get this in. But when you apply to the urban areas, it might be,
So basically those images are based on the high resolutions.
That's the chances are there, because of it. That's a good, I think it's the integration of this architect.
So I'm also his supervisor. When we are doing, when we collected the data, we were created a model. By using that one, it is a method that we can measure the distances not the extraction of that part. Okay, by using the points, it means the vertical heights and the
using the point cloud.
Yeah, by using the point cloud data.
No, yeah, if you're using the point cloud, but still the thing is, I am very doubt about the point cloud for the doors and door frames. Will it be able to get this point cloud for all these points? There may be chances are there. That's a wonderful.
I think
No, but the images they can look at, but I don't know.
we were not measured the louvers, sir. Only the frames. Yes, sir. Because yeah, not the details, sir. We can't go that much of because the 12 megapixel camera it was there. If it is greater than that one, then we can go for that one, sir. It's okay.
What is the pixel size finally?
12 megapixels, sir.
12.
Yeah. Because of that, we can't go when we are creating the point cloud. We can't create that densify crown point. That's the question, sir. Because if we can improve the pixel size of the camera, then we can create a densified cloud. And then we can measure the more details, sir.
Okay. Okay. Thank you.
Singhawansa, you have done I think a good research. So we are in an age of dual-use technology. From a military point of view, as you are a military officer, can this technology be used for military purposes?
Basically, I am trying to achieve this post-construction details. When we consider about the military scenario, if there's anything regarding the post-construction, which we have to take the details, of course, I can use these techniques.
Okay, more than for post-construction, actually, this UAV and drones are used for targeting. So this can be used for targeting if there'll be a time when you can study this. Once you pass out and you go, so this technique can be used for targeting purposes. Okay.
Thank you.
Okay, thank you very much. Any more questions? Seems very interesting research.
Yeah, Mr. Singhawansa, now you presented a very simple case study. I think you better go further into the details because you simply mentioned about the LiDAR and LiDAR technology. If you use LiDAR technology with the UAV, it could be, very easy to produce more accurate details of the three-dimensional nature. Yes. Because we have used it, we have used UAV vehicle with a LiDAR camera built, fixed onto the summit of it and flown over Ruanvelisaya and got all the details in a point cloud format and then interpreted it and drawn using the AutoCAD drawings. Right? So we presented it over the national TV also. We wanted to popularize that technology, but we could not do it because we could not get the relevant finances from Central Cultural Fund or the Department of Archaeology. Right? So because I saw in your presentation, the last word was LiDAR.
Yes.
So it would have been a much better way of doing using UAV and the point cloud to interpret architectural monuments and buildings. So we used it in one site which is very closer to Panduasnura. So that site, of course, by manually, the people at the site measured everything. Maybe they took more than 3 months to do the manual drawing because there are stems of columns and a lot of ruins. But using LiDAR within 20 minutes, we were able to make a point cloud and prepare the drawing.
Okay, thank you very much. Any more questions from the last presentation? Okay, then I'm certain we have many more questions. We can ask them from the speakers during our tea break. So now I think there are no more questions. So we now we are at the end of the first session. So let me sum up the session. The first presenter is Mr. K.P. Manuranga. He talked about the height datum unification. So he stated that it is a requirement, or it is essential to change the old vertical datum, local vertical datum into a new version. Just like we change Khandavala to SLD 99. So actually it is essential because the world has changed, so we should go with the changes. And the second presentation was about the land use and land cover change of the paddy cultivated area in Sooriyawewa. So we had suggestions to improve the research. I think the author agree with the suggestions, and we hope she will improve it in the future. And the third one is about flood, the effect of flood on the built-up environment. And she also got a lot of suggestions for the improvement in the future. And her work is also nice and acceptable. And the final presentation was very interesting and had a lot of questions and clarifications. It is about unmanned, the use of unmanned aerial vehicles for facade surveying. I think we can further discuss about this research during tea break. So now that's all for the first session. So now I hand over the session to the comrade.
Thank you, madam. Ladies and gentlemen, we have come to the end of the technical session on spatial sciences, and it is now time to award certificates for the presenters. To give away the certificates, I would like to invite the chair of the session, Dr. Wathsala Gunawardena. K.P. Manuranga and others. C.G. Malavipathirana and others. KGES Dias and others. JPC Singhawansa and others. Thank you, madam. Please remain on stage. I cordially invite the Rector Southern Campus, Major General LCR Jayasuriya, RSP, NDC, PSC, accompanied by Dr. H. Lakmal, Dean, Faculty of Built Environment and Spatial Sciences, to award a token of appreciation to the session chair, Dr. Wathsala Gunawardena. Thank you, sir. The proceedings of the technical session on spatial sciences are hereby concluded, and the proceedings of the session on quantity surveying will begin at 10:30. I invite you all to enjoy the refreshments served in the Design Studio 1 of faculty premises.